Alright, here we go with iChem lesson 17 on percent composition. You will need a periodic table and your calculator to be able to follow along. The first thing I want to do is relate this idea to something that you guys probably already have a pretty decent grasp on, the idea of percent composition. So this is happens to be my 4th grade class. What I want you guys to think about is how you would figure out the gender composition, the percent boys and the percent girls of the class. I think most of you would be able to discern the idea that you would count up all of the boys, count up all of the girls, and find the percent that way. So let's just do that really quickly as an exercise. So let me count the boys. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 boys. Let me count the girls now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 girls. It's girls. And in case you were wondering, that one is me. So add them all up. I have 14 boys, 17 girls, that's 31 total students. So if I wanted to find the percent boys, I would take 14 out of 31 times 100. And if I plug that into my calculator, what I end up is 45.2% boy. To find girls, I would do, there are 17 total girls out of the 31 in the class times 100 equals 54.8% girls. When we talk about percent composition in chemistry class, though, we're not necessarily talking about how many boys or how many girls are in this class. We're talking about the contribution by mass of each of the elements in a compound. So let's do an example. So percent composition in chemistry is often also called percent mass. So if I want the percent mass, just like the classroom, I wanted the amount of girls, I want the mass of the particular element, divided by the mass of the compound. This is the same thing as molar mass times 100. Okay, so how do I do this? Well, the first step is really just calculating the molar mass. And we're going to do that in sort of an exaggerated way to keep track of all of the elements. Okay, so I have iron and I have oxygen. I have 2 irons and I have 3 oxygens. The molar mass of iron from the periodic table is 55.85. The molar mass of oxygen from the periodic table, we're calling it from this point just 16. In general, I'd say go out to 2 decimal places, but oxygen goes 0.9999, so we'll just call oxygen 16. Now let's not just add it all up in our calculator, but take the time to figure out the contribution of iron and oxygen to the total. So 2 times 55.85 is 111.7, and 3 times 16 is 48. So the total molar mass of this compound added together is 159.7 grams per mole. Now to find the percent composition, to find the percent iron, I would do the mass of iron, all of the irons, so here, that's why I wrote it out like this, is 111.7 grams of iron per the total, out of the total, 159.7 grams of the compound, times 100, which gives me 69.95% iron. Now for oxygen. The total mass of oxygen is 48 divided by 159.7 times 100 gives me 30.05% oxygen. And one thing we know about percents is they have to add up to 100. So check yourself in the end. Plug in 69.95 plus 30.05, add it up. You should add up to 100%. If you don't, you made a mistake somewhere in your calculations. Now, I will say if you get 98.9 or 99 or 101, you're probably pretty close. It's just a rounding issue. You're okay. But if you get something like 85 or 92 or 120, you're making some mistakes. They're too far from 100. So let's just do one more example, and it's a slightly more complicated example. Finding the mass of all the elements in aluminum nitrate. So this should say nitrate. The very first thing we need to do is write the formula. You can't get any other information until you have the right formula. So it's an ionic compound. I'm going to start from my ions. Aluminum is 3 plus, nitrate is 1 minus. When I swap and drop, I end up with AlNO3, and then with a 3 out here. Now I need to find the molar mass of this compound. I have aluminum, nitrogen, and oxygen. We have to add up all of the elements together because we don't know the molar mass of a nitrate. Alright, so aluminum from the periodic table, 26.98. And I have 1 aluminum. I have 3 nitrogens because 1 times 3 is 3 nitrogens, and each of them is 14 grams per mole. And I have 3 times 3, which is 9 oxygens, and each of those is 16 grams per mole. So aluminum still sitting at 26.98. Nitrogen, I have 42, and oxygen, I have 144. So the total molar mass is 212.98. Now I've set up the equations. First for aluminum, 26.98, the mass of aluminum divided by the total mass gives me 12.67% aluminum. For nitrogen, I use 42 divided by 21298 gives me 19.72% nitrogen, and then oxygen 144 divided by 212.98 gives me 67.61% oxygen. Same as before, we know that as a percent they all need to add up to 100, so I'm going to plug all 3 of these numbers into my calculator, add them together, and check to make sure that I do in fact get 100%. Make sure that you're ready and able to do this tomorrow. If you didn't get all of the examples down, make sure you do so now. You're welcome to rewind. Don't forget to complete the Google form.